Welcome to Introduction to Computer Science 2. And by now you would have taken the prerequisite course, Cost 1046, which was Introduction to Computer Science 1. In the previous course, you learned the fundamentals of programming in Java. You touched on objects in Chapter 9, which was the last chapter before the end of the course, but you didn't get into objects in as much detail as we're going to now. In fact, most of the course you took was considered what we call procedural programming. The course code for this course is COSC 1047. Now we're going to look at Java from an object-oriented perspective. We're going to start by talking about the motivation behind why we're studying this. In Chapter 9, you did see some advantages of object-oriented programming, but the coverage was rather superficial. You learned how to declare classes and to instantiate objects of those classes, but it was somewhat mechanical, and now we're going to actually get you thinking in objects, and that in fact is the title. And that in fact is the title of this chapter. So we're going to get into objects in a much deeper way than you did in your first introduction to it in the tail end of your previous course in Chapter 9 of the text. Next, we're going to discuss the objectives of this particular lesson. You're going to learn to apply class abstraction to develop software. In doing so, you're going to develop somewhat of a split personality as a programmer, because now you're going to think separately about the objects you create and how they behave and how they're implemented and what they do from how you're going to use those objects. On large projects in large companies, there'll be teams of programmers, and some of them will work on creating the objects, and others will create the software that uses those objects. Generally speaking, when you're taking a course like this, you're both teams at the same time. But nevertheless, it's very useful to split your thinking up into what you're going to do in terms of creating objects and developing those objects and how you're going to use them as two separate things. And that is known as class abstraction. The next objective is to explore the differences between procedural programming and object-oriented programming. As was mentioned earlier, in your previous course, you studied procedural programming. You did touch on objects, but you didn't really think in an object-oriented way, and you certainly didn't extend object-oriented programming as far as it can be, and that's really the objective of most of this part of the course that you're taking. You're going to also discover the relationships between classes. Some of that material is rather deep and abstract in a way, but it's still useful to have exposure to it. And then finally, you're going to learn to design programs in the object-oriented programming by applying object-oriented thinking to your solutions as you develop them. Class abstraction and encapsulation is a very important part of object-oriented programming. In class abstraction, we make a distinction between the class's implementation and how we're going to use the class, which is the class interface. We can think of the class creator, the person that writes the class, and when they do so, they will worry about how they're going to implement the class, how they're going to make it work. And they merely provide documentation to the people that are going to be using the class, and that documentation will describe what the class is, what it does, and it will describe how to use the class. What it will not do is it will not describe how the class performs whatever functions it's supposed to perform. Those details are called implementation details, and they can be hidden from the user. And it's not so much that we want everything to be secret and private, but it's simply the fact that the programmers using the class have no need to understand or know anything about the implementation details. And by not having to expose them to those details, it actually makes their job easier, because all they need to worry about is, how do I use this class? So the implementation details, that is how the class does what it does, are going to be hidden or encapsulated from the user simply because they don't need to see those details, they don't need to know them, and not having to worry about them does make things easier for them. In your previous course, one of the examples you looked at was designing a loan. We're now going to revisit that example, but this time we're going to do it in an object-oriented way. As we develop more and more object-oriented programs, it will become more and more clear to you what the advantages of thinking in an object-oriented way are. On the left-hand side of this slide, you see what's called a UML diagram, that is Universal Modeling Language diagram. It's used to show the construction of a class. There's no implementation details here. We don't know how the class is going to work, and we aren't showing any programming code that would indicate how these functions are going to do what they need to do. But we simply are showing the interface for the loan. We're giving information to somebody using this class, called the loan class, that they need to know in order to use the class. That, of course, clearly is going to exclude implementation details. We can implement this class in any way we like, and the users of the class don't need to know the details of how we did our implementation. You'll notice that the UML diagram consists of 3 vertically stacked boxes, and the box at the very top is simply the name of the class. The box in the middle has dashes beside each item, and that indicates that these are data members, pieces of data to be used within the class. And finally, the box at the bottom, consisting of strings preceded by plus signs, indicates methods that are used by this particular class. It is going to be through the methods that people using the class are going to have access to the class and to what it does and what functionality it provides. By now you've already learned about picking appropriate variable names that are meaningful, and the strategy that we use in Java of capitalizing individual characters within the variable name to indicate different words, and always starting with a lowercase. That tends to be the convention used in Java programming. So you're familiar with that, and if you look at the variable names that exist in that middle box, annual interest rate, number of years, loan amount, loan date, you can see that we follow that strategy, and of course we'll continue to follow that strategy throughout the rest of the course. The type of each of those variables is indicated on the right-hand side. So the first is a double, then we have an integer, then a double, and then a special type called date. There are default values associated with each of these in some cases, not all. There's no default date. You can see to the right-hand side of the actual UML diagram is an explanation of each of the variable names. Of course, the variable names used are very suggestive of what they mean. You can almost tell by looking at them what each of these pieces mean. However, just to be clear, beside each of those variable names on the far right-hand side, you see a English verbose explanation of what each of those variables are. So we have the annual interest rate of the loan, and there's a default value there of 2.5. The number of years for the loan, once again a default value, this time 1. And the loan amount defaulting to 1,000. So these defaults are values that are going to apply in the event that the person using the class doesn't specify any particular values. And finally, the date the loan was created, and there is no default value for this because it will always be the current time and date. Finally, we have all of the methods that are going to be used in this loan. And once again, we have suggestive names picked for each of these methods on the far left in the bottom of the UML diagram, and an English explanation, a more wordy explanation about what each of these methods do on the far right-hand side outside of the UML diagram. You learned already about constructors in Chapter 9, so you know that these are special methods that are called automatically when an object of this class is instantiated. So when somebody uses this loan class and makes a loan, by default, the first method will act as the default constructor. There are no parameters passed in here, and what will happen is all of the default values will kick in. There's another variation of the constructor, the one below it, the second method that you see in the UML diagram on the left, and it has the same name, loan, but this time you'll notice there's a number of arguments or parameters present in brackets after the name loan. In this case, then the default values are not going to be used, but rather the user of the loan class is going to provide specifically a particular interest rate, number of years, and a loan amount. Once again, the date is still going to have a default value, specifically the current time and date. You'll notice that all of the remaining methods in the class begin with either get or set. That's typical in object-oriented programming, and in fact we affectionately call such methods getters and setters. A getter is a method that returns the value of one of the data members to the user of the class, while a setter allows the user to alter or change one of the data members. In some cases, we might have data members that we don't want to expose to the user, and in such case we call that information hiding. There may not be any need for the user to have access to certain data members, and that would be one reason why we would do that. So all of the getters and setters serve similar functions, and there's no need now to go through them individually, but you can read through that later on your own and have a look at each of the individual getters and setters and see what they do. What we're going to do now is go out to the IDE and have a look at a program that actually implements this class and uses it.